Greetings. I have been asked to present a short lecture about the unit conversion of length and area. Now, a metric system of measurement is closely related to our number system, which is based on place value system. So in metric system of measurement, we go with powers of 10, positive and negative, as a matter of fact. I have the picture. I will put it shortly on the bulletin board to make it more explicit. Now, unfortunately, this is not the case with the English system. Now, in metric system, for length, area, and volume, we have only one unit, and that is meter. But this is not the case, unfortunately, for the English system. In English system, we have multi-units of measurements. And we have inch, we have foot, we have yard, we have mile, and we have acres. And to convert them is not based on, we need the conversion factor, and a little bit more arithmetic is involved. So they are not as simple as in a metric system. Now, there are three methods we use to convert units either within the system itself or from two different systems. And they are as a formula, a ratio proportion, and dimensional analysis. The latter one, the dimensional analysis, is the easiest method to use. Now, before I start, let me say a few words aside about why dimensional analysis works. It's very important, especially for the beginner. We don't take anything for granted. Now, A equals to A. We call it reflexive law, which is one of the axioms of equality. Now, where A and B are number, or they are mathematical expressions representing numbers. A equals to A. But by the way, this is not, you shouldn't take it for granted that is for everything. It depends on the relation. For instance, for derivative, a number is a variable is not derivative of itself most of the time. And also, let's, for example, say about fatherhood, I'm not my own father. So the relation that we are talking about, reflexive relation, holds for equality and is one of the axioms. An axiom is something that we cannot mathematically prove. It is a foundation that we build everything. Without axioms, we will be having circular reasoning, and we cannot provide logical reasoning for our mathematical system. So they play a very important role, the axioms. Now, the other thing is that A equals to B means what? Means B can be replaced for A. I come back to that also. Now, when we say A equals to B, where A is not zero, or is not a mathematical expression that can assume zero, then A over B is equal to 1. Do you follow me? And I say A equals to B. Now let me make examples so that it becomes more clear. 6 is a composite number. And 2 times 3 are the prime factors of 6. Now, 6 equal to 2 times 3. Is that right? 6 is a composite. 2 and 3 are what? Are prime. 6 divided by 2 times 3 is equal to 1. Even though what? Even though one of them is composite, the other two are primes. And same is true with 2 times 3 over 6 equals to 1. And 1 plays very important role in mathematics. 1 is identity for multiplication, meaning that every number times 1, the identity of that number is not changed. Every number times 1 equals to itself. In contrast, also 0 is identity for addition. Any number plus 0 equals to, identity of that number is not changed, equal to itself. Plays very, very important, these two numbers in mathematics for developing identities, and also many problems we cannot solve without them. I can go tons of them, I can talk about the benefit of 1 and 0. So these 1 and 0 are going to come, not 0 in this case, but 1 is going to come and show us why the dimensional analysis works. Now I come back when I make example, you can see that. Okay, then let me see. I have a lot of things to put on the board for you to kind of reduce the time. So let me zoom this one and stay out of way so that we can go and over them on the bulletin board. May I please? Okay, now we were talking about what? We were talking about metric system of measurement. Now look, for example, if we want to go from kilometer to meter, we go from kilometer to hectometer, which is what we multiply by 10, then which means what? Each kilometer is 10 hectometer, and each hectometer is 10 decameter, and each decameter is 10 meter. So it's 10 times 10 times 10, which is 1,000. Therefore, 1 kilometer is 1,000 meter. You follow me? And we can do exactly the same thing to go backward. To go backward, we go from meter to decameter, and then from decameter to hectometer, and from hectometer to kilometer, and see how many, what is the relation between meter and kilometer. You see that? So in this case, we are dividing by 10, or we multiply by 10 to the negative power. So this picture is very good, and in a live class, of course, I will distribute them. Okay, now let me go to next one and make sure it is zoom, the one that I mentioned about a skinny one. I call it a skinny one. It's my favorite number. Let me see if it is zoomed. Looks good. Okay, let me go one more time through that. We are talking about why dimensional analysis works. Now, the answer is that 1 is what the identity for multiplication. I have gone over that. Any number times 1 is equal to itself. Is that right? And just any expression times 1 is equal to what? Equal to itself. Now, A equals to B, as I already mentioned, B can replace A. That is an axiom. And then A equals to B, where A is not 0, or if it is expression, does not assume any value of 0, then A over B equals to 1. Then I went through the example of 6 to be a composite number, and 2 and 3 are what? Are prime, but when we divide them, you see 6 divided by 2 times 3 is 1, or 2 times 3 divided by 6 equals to 1. That is exactly if you say I have $5, and then $5 times $1 is 120. So that is 1. So I'm left with my same $5. Nothing has changed here. All right? So we come back to that again. Now, let me go to dimensional analysis by this, and now we know why it works, and when I go over that, I explain it further. Now let's cover this one, some of them that we don't need. Now, we want to use the dimensional analysis to convert 2 kilometer to centimeter. We want to know how many centimeters are in 1 kilometer. We don't want to follow that step. We want to follow dimensional analysis, all right, in a metric system. So what we do here, look at this one. 1 kilometer is 1,000 meter. Is that right? Like 6 equals to 2 times 3. So 6 divided by 2 times 3 equals to 1. So 1 kilometer divided by 1,000 meter is 1. And same is true if I say 1,000 meter is 1 kilometer, and this is also 1. I call it a skinny one. Do you follow me? And I have that example. Now, let's go and see, knowing this one, the other thing that we know also is that 1 meter is 100 centimeter. Is that right? 1 meter is 100 centimeter. Let me put this one off here. And all we can say 100 centimeter is 1 meter. So this is a skinny one. This is 1. Again, 6 divided by 2 times 3 is 1. Very, very similar analogy. Now, let's go to conversion. So conversion is this now. If I may now put this one here and go through this way. Now, I write 2 kilometer equal to 2 kilometers. Is that right? This is by what? I already mentioned, we call it reflexive axiom or reflexive law of what? Of equality. 2 kilometer equals to 2 kilometer. Now, I go for the dimensional analysis. Now, I multiply by 1. Is that right? When you multiply by 1, it doesn't change. So the one that we mentioned here can be, what can be 1 kilometer is 1,000 meter, or it can be 1,000 meter is 1 kilometer. Which one of them do we use? If you by trial and error, if you make mistake to use one rather than the other one, you haven't really harmed anything. This equality holds. But the reason I selected 1,000 meter over 1 kilometer, because I want the kilometer and kilometer, but they cancel each other. So the unit, the dimension are cancelling. Kilometer and kilometer are cancelled. So I'm left with meter. But that is not what I had in mind. I wanted to go to centimeter, not to meter. So I go one step further. All right? Now, a step further is that here I know that 100 centimeter is 1 meter. Same is true, 1 meter is 100 centimeter. But I select that one because the meter, the unit meter and the meter of this one, they cancel each other. This meter and this meter, they cancel. So I'm left with what? I'm left with centimeter. Hooray! That means exactly what I wanted to catch. Lo and behold, I got that one. Okay, then the rest of them is just numerical arithmetic calculation I made. So I write 2 kilometer equals to what? Equals to 1,000 times 100 is what? 10 to the 5. So 2 kilometer is 2 times 10 to the 5 centimeter. That is what dimensional analysis. Now let's go and do the same thing with area, because I have been asked to do it for length and also area. So let's go now for the area. For the area, let me first give a short talk so that is prepared to better comprehend the concept. Suppose that I have a land which is, let's say, 1 mile by 1 mile, a square mile. 1 square mile by 1 square mile. All right? Now, I want to see how many square centimeter, let's say, can fit in this land. I have some reason for that, maybe for planning or agriculture or something. I have to determine that one. Now, 1 mile, 1 kilometer by 1 kilometer, 1 kilometer is what is 1,000 meter. Like you remember I said 6 is 2 times 3. So instead of 1 kilometer, I can write what? I can write 1,000 meter. So the dimension of that was 1 kilometer by 1 kilometer, which is 1 kilometer square, now becomes 1,000 meter by 1,000 meter, which becomes what? 1 million square, what? A square meter. Before was a square kilometer, now becomes a square meter. That means this is really out of scale, but that means if this is one of the 1 meter by 1 meter, I will have 1 million of them I can fit in that. Again, if I have some need for that for agricultural purposes or something. You follow me? No, but the purpose was to change it into centimeter square. So I go and look at one of them. I see this is 1 meter by 1 meter, but 1 meter, the dimension of this one is 1 meter by 1 meter, which means this is 1 meter square, but I'm looking for what? 1 centimeter square. So 1 meter is what? Is 100 centimeter. So this becomes 100 by 100 centimeter square, which is what? 10,000 centimeter square. So 10,000 square of centimeter I can fit in this unit. And there are 1 million of them. So 1 million is 10 to the 6, and I have this one 10 to the 4. That means 10 to the 10 a square centimeter I can fit in my land of 1 mile by 1 mile. So let's not do that one by dimensional analysis. So this is the interpretation of that, huh? So let's now convert the 1 kilometer square to centimeter square using dimensional analysis. Okay, now here let me see if I have to cover something just for the eye purposes. Now here we want to go from kilometer square to centimeter square. So look what happens. Again, I go through the same thing. I have 1 kilometer, I have 1 kilometer square equals to 1 kilometer square. That is a reflexive law or reflexive axiom for equality. Now, what will be my skinny one? My skinny one in this case is I have 10 to the 6 meter square. You remember 1 million from the demonstration I made? In 1 kilometer square. Now, the denominator, kilometer square and kilometer square, they cancel each other. We don't cancel the numbers. We don't simplify numbers yet. We do it at the end. So, kilometer and kilometer, they cancel. Now I'm left with meter square. If I was interested on meter square, that's the end. That's it. I have got my answer. But he wants centimeter square. So I go 1 step further. And what is my first 1 step further? I go again, a skinny one is doing the job. I know that 10 to the 4 centimeter square is in 1 meter square, as I demonstrated in that square. All right. Now meter square and meter square, they cancel each other. Now look what happens. I have 10 to the 6 times 10 to the 4, which is 10 to the 10 square centimeter will be 1 kilometer square. And I have the numbers here for you. That is dimensional analysis. Now, let's go and do this one. This is for area. Now let's go and do that for 2 different systems. Let's go from, let's say, from English system to metric system and see how we can convert them from one system to the other using, again, the dimensional analysis. So let me cover this one. I think I use this. I want to convert 5 mile to kilometer. I want to see 5 mile is how many kilometers, all right? Using dimensional analysis. Now look what we do. I go 5 mile equals to 5 mile. Is that right? We call it reflexive law or axiom of equality. All right? We keep that one. Next step. Next step is we know that one, that 50 to 80 feet are in 1 mile. You follow me? So that is my skinny one. Remember, 6 equals 2 times 3? So that's exactly what I'm doing. This and this is our divide. They are in a sense same as 6, and 6 is a composite number. 2 and 3 are prime, but when divide 6 by 2 times 3, we get 1, and that is exactly happens here. So this is really 1. So I multiply 5 mile by 1. So I'm not changing what was given to me. Everything is remains same. Any number times 1 equal to itself. So okay, so now here, mile and mile, they cancel each other. Look at that, let me do that. Mile and mile, they cancel each other. Is it clear? So I'm left with what? I'm left with feet. Now I have to get rid of feet because the purpose is to end up with kilometer. So now, what is the next step I go is this one now. Now I have to get rid of feet. So what is the relation? I know that 12 inches is in 1 feet. Same is true, 1 feet is 12 inches. But if I write 1 feet over 12 inch that way, then when I multiply, I get feet square. But that is not my purpose. My purpose is end up to be to cancel feet so that somehow I reach kilometer. So here, what happens now, feet and feet, they cancel each other. Again, don't cancel numbers. Leave the simplification numbers for the last one. So here, feet and feet, they cancel each other. So I'm left now with inch to get rid of it because I want to end up with kilometer. I have this in my mind. So next step is this one. 5 mile again equal everything is same. Now my skinny one in this case to get rid of 1 inch is 2.54 centimeter is in 1 inch. Something that most of us do know about. Alright? So there are 2.54 centimeter in 1 inch. Now inch and inch they cancel each other, so I'm left with centimeter. Now I'm in metric system now, already. You follow me? So the next step is to change the centimeter into meter and then into kilometer. So looks like I'm close to the end. Okay, then next is this one. Let me not cover that one and go through this one. Now here, again, 5 moles equal 5 moles, and feet, they had already cancelled each other. Feet and feet, they cancel. Inch and inch, they cancel. And now I have centimeter, 2.54 centimeter is 1 inch. Centimeter and centimeter, they cancel each other. So I'm left with meter. Now I have to change meter into kilometer, which is the last step, which is very simple. So I have that one in the next. There was no room, so I put it in the next sheet. So let me go to the next. Now, let me also cover this one. Now again, to go over it one more time, is mile and mile, they cancel each other, you see that? Feet and feet, they cancel. I didn't do anything with the numbers. Inch and inch, the unit cancel. Centimeter and centimeter, they cancel. Meter and meter, they cancel. So I'm left with kilometer. And 1 kilometer is 1,000 meters. So all the units are cancelled, so I'm left with the numbers, and I go through the numbers and multiply and divide. And here it is the final answer, which means 5 times 5,260 times 12 times 2.54 divided by 10 to the 5. 100 times 1,000 is 10 to the 5, the denominator. So the answer ends up to be 5 miles is 8.04 kilometer. Okay then, I hope that I have conveyed the subject that you have asked from me, and I hope that this I'm doing also all of my channel, every single of my videos are for the benefit of public I'm doing. And as I have already asked my students that if they have any topics they want me to present, please mention it in the comment section below. And if I notice it, I will make a preparation for such a lecture. Okay then, I thank you very much for watching, and I wish you all prosperity and good health, and please stay and remain healthy. So long.